In this short video, we're going to look at what a polynomial function is, definition of it, and also how to graph some basic polynomial functions that are transformations of, for example, x cubed, or transformations of x to the power of 4, using the transformations knowledge that you should have from the previous chapter, section 2.5. So you remember how to move things to the left, move things up and down, and so on. Well, we'll be doing that later in this video. Now, to start off with, what's the definition of a polynomial function? Well, it's a function that looks something like this. Well, this looks a little bit confusing. Maybe this expression here might give you a better idea. This example here is an example of a polynomial. It has a number and then an x to the power of something, another number and x to the power of something, ending with some kind of number. This big expression here is the same kind of thing. An is just a number. In this example here, the an would be equal to 4. The a naught is just a number. The a naught here is -7. It's just that in between here we have as many powers of x as we need. We might have x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4. This might be x to the power of 5. This might be x to the power of 6. The leading this thing here, the 4x cubed in this example, or the an x to the power of n, is called the leading term, and the an is the leading coefficient. Okay, so in this example here, 4x to the power of 3 is the leading term, with 4 being the leading coefficient. In this example, this part at the end that doesn't have an x in it is called the constant term. The constant term because it doesn't change according to what x is. If x changes, -7 stays as -7. And the other thing to mention is that the highest power of x, here we've got x to the power of 1, x to the power of 2, x to the power of 3. The 3 is the highest power of x, the highest exponent. And that 3 is what we call the degree of the polynomial. So the degree of the polynomial is the highest power of the polynomial. In this example, the degree of the polynomial is n. Okay, so for polynomial functions, they always are smooth. There are no big jumps in them, no holes in the function, no asymptotes. They're always fairly smooth, a little bit like this function here on the right. All these things here are examples of polynomials, but in these examples they only have, you can see they just have one term. This one's y equals x, y equals x squared, y equals x cubed. They're technically called monomial functions because they just have one power of x. So sometimes we have just transformations of the basic functions. The basic functions for polynomials you can think of as being like these ones. So sometimes we'll be looking at, for example, -x squared, and that would be a function, would be x squared that would be turned upside down. And then sometimes we'll be doing a transformation where we shift this function to the right or to the left or up or down. Notice, please, about these monomials, that anytime we have an even power, like x to the power of 2, x to the power of 4, x to the power of 6, we've got something that's it's like a happy face, if you like, a happy smile. Starts up at infinity, ends up at infinity. Whereas if you have an odd power, like for example x to the power of 3, x to the power of 5, it's kind of a squiggle, if you like. Squiggle like this, or a squiggle like this. Starts off at -infinity, goes up to positive infinity, negative infinity up to positive infinity. Now you remember, I hope, from the work that you did on transformations, how to shift something up, you add to the function. To shift down, you subtract from the function. To move something to the right by 2 units, for example, you would replace x with x minus 2. To move something to the left by 2 units, you would replace x with x plus 2. If you wanted to stretch something, you multiply by something. If you wanted to stretch something vertically, that is, you multiply by a number bigger than 1. To stretch something or compress something horizontally, you replace x with ax, where a is bigger than 1. If you want to turn something upside down, reflect it in the x-axis, do negative before the whole thing. And if you want to reflect it in the y-axis, replace x with negative x. Now, these examples are done for you already, but just a quick explanation as a reminder. If you want y equals x squared plus 3, well, look up what y equals x squared looks like. It looks like the shape I'm tracing with the red dot. You'd have to then add 3 to that, so shift the whole thing up by 3 to make this graph. That's y equals x squared plus 3. And if you want y equals x plus 1 squared, like this function here, well, what you need to do with that is move it 1 to the left. So start off with your function with the vertex at 0, 0, and just shift that vertex 1 to the left. So we have this function. Now if instead it's x, you have an x cubed thing that's been transformed. Remember, x cubed kind of was a squiggle starting off bottom left, going through 0, 0. There was a kind of strain, we call it a point of inflection, where it stops being unhappy and starts being happy at 0, 0. That point 0, 0 has been transformed, it's been translated 1 to the right, because we've replaced x with x minus 1. So this point moves over to 0, 1. We can perhaps zoom in on that a little bit more. This point here at 0, 0 has been shifted 1 to the right to be over here. Now if we look at this function here, which is the x cubed minus 2 function, right, this one here, you can see that the same function, that y equals x cubed function that we had, has been shifted down by 2 units. So what used to be at 0, 0, there used to be a point at 0, 0, has been shifted down 2 units. And the whole graph has been shifted down by 2 units.